3. All right. Yeah. Start chapter. Okay. Chapter 3, let's take a look at the overview. The syllabus includes what? It includes a few things. Now, the graph of y equals mx plus c is something that we are quite familiar with. It's a straight line graph. This is a quadratic graph, quite familiar. These two, I will jump quite quickly because this is quite a small of a revision. These three, piecewise, periodic, and parametric, these three are new concepts which I need to spend a little bit more time. Alright, but the first two, I will go a bit faster. Okay? Now, the preliminaries, I don't think I want to go through. This is the x coordinate, y coordinate, I think we are quite familiar. Graph, I don't think we are. I think all of us are good. Now, basic graphs, like I said, the linear graph is y equals mx plus c. What does m represent? Radian, very good. Excellent. So I think in your class, you may have gone through quadratic function. May or may not. It's okay. Right? Now, example 1. Let's take a look. Example 1 is this. Find the value of k such that the line y equals to kx plus minus 2 is a tangent to the curve. Now, tangent means what? Tangent, tangent to the curve. That means it does cut. That means you have a curve, whatever, and then you have this is a tangent. Correct? Yes, this means a tangent. So, tangent means that I can intersect this one. I will equate x squared plus 2x plus 7 equals to kx minus 1. Surely I will have an intersection point because this is a tangent to this. So surely there is an intersection point. All so far so good. Now, but you take a look at this. This is a quadratic equation with x as a variable and then also has k. So one equation has two unknowns, unlikely to be able to solve. Am I right? Right? Unlikely to be able to solve one equation, two unknowns. But the key word here is tangent. If it's a tangent, it means that this quadratic equation x squared plus 2 minus k x plus 9 equals to 0. This quadratic equation, I simplify this, I bring this k across, etc. This quadratic equation has in order for it to be a tangent, the quadratic equation must have two real and equal roots. For it to have real and equal roots, the discriminant must be equal to 0. Right? Familiar? So I'll move fast. I'll move fast. Okay, it's all written for you. For it to have real and equal roots, therefore your k must be 8 or minus 4. But I don't want to go through too much in detail. Okay? All good? Am I going through too fast? No? Okay. Let's move faster. Alright. Exponential functions. Okay, test y'all without using the GC. Do you remember how this graph looked like? Y equals to EX. Can sketch confident? Then use pen and draw now. Or pencil, not confident. Okay lah, pencil lah, whatever. Doesn't matter. Do it on your own. Check with your friends. Wow, generate so much discussion. By right shouldn't, right? Right, Maxon? Maxon, calling you. You know how to sketch, huh? Sketch now. No, on your paper. Okay? Wow, I didn't expect this to generate so much discussion. Now, okay, thank you. Okay. Come back. We need to go a bit faster. Cannot. This one cannot spend so much time. Okay now. If you have a graph, y equals to ax, where a is greater than 1, that means it can be 2, 3, 4, 5, that means 5 to the power x. Example is e to the power of x. This graph looks like this. Yes? This graph looks like this. What about if you have A is between 0 and 1? That means you have example 1 over E, this kind of graph. How does this look like? A bit harder, is it? It's a bit harder. Actually, it makes sense. This graph looks like this because you think about it. If you have substitute x is very big, then your e to the power of very big number confirmed is very big number. Make sense? If you substitute x to be negative 1000, example I said negative 1000. No need 1000, 100 will do. Then your y is e to the power of minus 100. Now, when you have e to the power of minus 100, is it a negative number? No. It is just 1 divided by e to the power of 100, right? What is e to the power of 100? A very big number. You take 1 divided by a very big number, what do we get? Super small number. That's why 10 is 0. Are you following me? Yes, huh? Okay, very good. So therefore it makes sense. This graph will always lie above the x-axis. It will never lie below the x-axis. Because e to the power of anything will always be positive. Make sense? Oh, good. Now, what about this guy then? You use the same idea. Can we deduce the graph of this one? You think about it. You sub x equals to 100. You get e to the power of minus 100. What do we get? Suddenly very quiet. Understand or not? If I sub x equals to 100 here, I get e to the power of minus 100. I get a very small number. Very close to 0. I sub x equals to minus 100, I will get e to the power of 100. I get a very big number. So this curve goes this way. It's actually a reflection. Oh, sorry, don't touch. Wait. I better not let you all copy wrong thing. It's actually a reflection of this graph. Shaking, right? Scared. You want to draw wrong thing. Now, it's actually a reflection of this graph in the y-axis. Does it make sense to all of us? Yes? So now if your base A is bigger than 1, is upward sloping like that. If base A is between 0 and 1, it's downward sloping. Oh, good. Now, focus on a few things. What is this? The graph has an asymptote y equals to 0. That means y equals to 0, this is actually the x-axis. What do we mean by asymptote? An asymptote is a line where the graph gets closer and closer as the x or the y values gets larger and larger. It actually means the tail end behavior. What do we mean? Actually, this graph gets closer and closer to y equals to 0 without actually touching it. It will never touch it. Why? Because if you sub x equals to minus 100, you will get e to the power of minus 100. Very close to 0, but not 0. Even if you sub negative 1000, you will get e to the power of negative 1000. Very close to 0, but never 0. So no matter what value you sub here, you will never touch 0. But it gets very, 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 very close to 0. Oh, good. 10? Okay, that's what we mean by asymptote. Alright? So, this one, the asymptote, is also y equals to 0. The rest, I don't think I need to say more. This is interesting. On GC, now we make it a habit. I told A12 yesterday that for every math lesson, you must bring your GC. So for lecture, also the same thing. You must bring your GC. Okay, please bring your GC. Okay, I can forgive you if you didn't bring today, but subsequently, please bring your GC. Okay. Now I just want to show us. Oh, not here. Okay, never mind. If you sketch this on your GC, let me do the GC. GC is here. Yeah. Okay. What is that? Never mind. Okay, already. Okay, if you do this on your GC, you sketch e to the power of x. So 6. Now, this is what you see on the GC. Okay? Can? Alright? Cannot follow, never mind. It's okay, I just very quickly do this. You can actually sketch e to the power of x on your GC. See, you get e to the power x. Then you go to graph. Now, what I want to highlight is this. On the GC, you can see that the graph actually touches the y-axis. So who should you believe? You should believe the nodes or should you believe the GC? Very good, nodes. Why? Because the GC cannot show HD resolution. You follow what I'm saying? Or it looks like it's touching, but actually it's not touching. You cannot. Unless you zoom a little bit more, you can zoom in. You realize that the shape, you can see a bit clearer. Okay. Zoom box. If you can zoom in a little bit more, you draw a box. Then you can see the shape a bit more. Then you see, okay, yeah, now it really gets closer and closer. But it still looks like it touches. But no, it wouldn't touch. You must trust your analysis rather than trusting the GC in this case. Follow? Can? Okay, let's move on. All okay, huh? Okay, log functions. Now you all can use GC to sketch the log function. Can? I leave it to you. Can recall? Challenge yourself. If you can recall, just draw without the GC. If you cannot remember, then draw with GC. Either you recall what your level memory or you want to finish it GC or do a zero. Well done. Alright, some of us got a straight line. First tip I would give all of us is this. When you use the GC, alright, when you use the GC, typically, maybe the IP students can help. What do we do? When you have ln x like that, and can close the bracket, what we always do is, want to see, zoom. Zoom. You press zoom, and then you press 6 for zoom standard. What does it do? You can see some nicer looking graph. It actually is not a universal answer to all graphs, but what at least it does is, you are telling the GC sketch from -10, x goes to -10 to 10, y goes to -10 to 10. You can see something, but it may not work all the time. Zoom 6. So, let's go back to the notes. I know you have seen the answer on the below here. Now, you realize that what I showed you just now and what you see here is a bit different. That's because this one, some Windows settings have been adjusted. I'm not going to go through it now. You can maybe go to tutorial and ask your tutor. Okay? But for ln x graph, you're right, it looks like this. Yes? Now, this is for the base bigger than 1. Your A is bigger than 1. Take note, your base is bigger than 1. Now what happens if A is between 0 and 1? That means like this 0.2 log 0 base 0.2. If you do a change of base formula, if you recall, change of base formula, it is ln x divided by ln 0.2. Now, can you tell me ln 0.2, is it a positive number or negative number? Negative or positive? Negative, is a negative number. Ln 0.2 is a negative number. So you take a negative number times ln x. So whatever that was positive here will be reflected below, whatever that's negative here will be reflected above. So the answer to this is as long as your base is between 0 and 1, then the graph looks all good. Can I? Okay, I'm going through quite fast because I think you all can handle this. Okay? How do you key in log to base? Now this is the power of GC. I told A12, you all must like the GC. And I show them how to, that actually it's not bad. In your scientific calculator, you cannot key in log to base 0.2. In the GC you can. I show you how to key in log to base 0.2. Very good, really. Trust me. Let's say you want to key in log to base 0.2, right? You press alpha window. Okay? Yeah. Alpha window to bring up this menu. You see number 5? You press 5. There you have it. Log to base 0.2 x. Zoom 6. Yeah, from there. Can you see the keystrokes here? Never mind, if you miss this, you just do this. Alpha window 5, 0.2, blah, blah, blah. Okay? Convinced that GC is good? Yeah, GC is good, really. And then another question, someone asked, can we bring the scientific calculator into the exam hall? Yes, you can. You can bring 2 calculators, don't worry. Oh? Okay. Let's move on. Okay, this is revision. Let's go to piecewise function. But before that, let me stop this recording and we start on.